In this video, we're going to take a look at prime factorization. Let's review what factors are. Factors are numbers we multiply together to get another number. So for example, if I wanted to find the factors of 24, they would be 1 multiplied by 24, 2 multiplied by 12, 3 multiplied by 8, or 4 multiplied by 6. Those are factors of 24. A whole number that cannot be made by multiplying two whole numbers together besides one in itself is known as a prime number. So for example, 3 is a prime number because the only factors for 3 are 3 times 1. 5 is a prime number because the only factors are 5 multiplied by 1. 7 is a prime number because the only way we can get factors for 7 are 7 times 1. A whole number that can be made by multiplying other whole numbers together is known as a composite number. So, for example, 10 is a composite number because I can do 1 multiplied by 10 and 2 multiplied by 5. 24 is a composite number because I can do 1 multiplied by 24, 2 multiplied by 12, 3 multiplied by 8, and 4 multiplied by 6. 1 is neither prime or composite because it only actually has one factor, and that is itself. So it does not fall into the prime category. It does not fall into the composite category. Let's talk prime factorization here. So we know what prime means. Prime is any number that has factors of 1 and itself. And we know what factors are is numbers multiplied together to make a number. So prime factorization is where the numbers we're multiplying together are only prime numbers. And a tool we use to find prime factorization of a number is known as a factor tree. It can find any factors of a number, then we factor those numbers, and we keep going until we cannot factor any more to any more prime numbers. So let's take a look at 72. So we're going to use our factor tree, and we're going to try and get down to the prime factorization, or only the prime factors of 72. So I know that two factors of 72 are 2 multiplied by 36. Once I do this and find these factors, I want to ask myself, are either of these prime? Well, 2 is prime because the only way I can get 2 is 2 times 1. So I'm going to circle that one because I'm going to stop there. 36 is not prime because I can go and take 6 and multiply it by 6. Again, I'm going to ask myself, are either one of those prime? No, because 6 can be broken down into 2 multiplied by 3. And same thing with this 6, 2 multiplied by 3. So again, I ask myself, are either of these factors prime? Well, I know from before 2 is prime, so that's done. And I also know that 3 is prime because the only way I can get 3 is 3 times 1. So now I have all of my prime factors for 72, which would be 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by the last 3. And again, I'm putting them in order from smallest to greatest. Now I can shorten this up because I can take my expanded form and write it into exponent form. So right here I have groups of 2. How many 2's do I have? I have 3 of them. So again, I'm multiplying my 2 by itself 3 times, which can be written as my base of 2 and my exponent of 3. And then I have 3's here. I have 2 3's, so I can write it as a base of 3 with an exponent of 2, and they are being multiplied together. So there would be my prime factorization of 72 is 2 to the third power multiplied by 3 to the second power. Now I have 180, and I want to do the same thing with that. So I'm going to break it up into 2 factors. And for me, the easiest one that I see is 10 multiplied by 18. Are either one of these prime? No, because 10, I can go 2 times 5. Now, before I move to 18, I want to check, is 2 or 5 prime? Well, both of them are. So I'm going to circle those and I'm done with that side. Now I'm going to go to 18. Well, 18 is not prime because I can take 2 and multiply it by 9. 2 is prime, so I'm going to circle that one. 9 can be broken up into 3 times 3, which is prime. So I'm going to circle both of those. So now I'm going to list out my factors here. I have 2 times 2. I have 2 3's here, so 3 times 3. And now I have a 5. So here are all my prime factors of 180. Again, if I look at here, right now I have it in expanded form and I want to put it into exponent form. I have 2 times itself 2 times, which is the same as 2 squared. I have 3 times itself, so there's 2 3's there. So that's 3 squared. And I only have 1 5, so I'm really not going to do anything with that. So my prime factorization for 180 is 2 squared multiplied by 3 squared multiplied by 5. I don't need to put a 1 up above the 5 for an exponent because 5 to the first power is still just 5. Here I have 135. I know that 135 is divisible by 5 because it ends in a 5. So when I do that, that's 5 multiplied by 27. Well, I know that 5 is prime, so I'm going to circle that one. And then 27, I can do 3 multiplied by 9. I know that 3 is prime, so I'm going to stop there. And then I'm going to take my 9, and 3 multiplied by 3 is 9. And I know that both of these are prime. So now I'm going to make a list of my prime factors. And I have 1, 2, 3 3's. So I'm going to have 3 multiplied by 3 multiplied by 3. And then I have 1 5. So multiply that by 5. Well, again, this is an expanded form. So I'm going to kind of simplify that down to exponent form. So here is 3 times itself 3 times, which is 3 to the third power. And then I have multiplied by 5. Again, I can just put 5. I don't need to put 5 to the first power. So my prime factorization for 135 is 3 to the third power multiplied by 5. Here I have 224. I know that 224 is even, so I can divide it by 2. And that would give me 2 multiplied by 112. 2 is prime, so I'm going to stop on that side. 112 is even, so again, I can divide it by 2, and that gets me 56. Again, 2 is prime. 56 again is even, So I can divide it by 2, and that gives me 2 times 28. Again, 2 is prime, 28's even. So I can do 2 multiplied by 14. Again, 2 is prime. And then 14 is 2 multiplied by 7. Well, 2 is again prime, and so is 7. So when I write here, I have 1, 2, 3, 4, 5 twos. So 2 times 2 times 2 times 2 times 2. And then I have my 7 times 7. Well, again, it's an expanded form. So I'm going to take and look here. I have 2 times itself 5 times, which gives me 2 to the 5th power. And then multiplied by 7. And again, I just have 1 7. So my prime factorization for 224 is 2 to the 5th power multiplied by 7.